Again, welcome back to Precalculus class. This lecture cover the rules of integrate exponents. So our main objective again is go through all the rules for again integer and exponents. So our first rule will be a multiplication rule. Now here, if we have, let's assume a, m, and n can be any value. So here we say for any real numbers a and b, and also the positive integers m and n. So if I have a to the power m times a to the power n, now if the base are the same, here we have a and a, they are the same, we had the exponents. So here the result will be a m plus n. Also in division, if we have a to the power m divided by a to the power n, we are going to subtract the denominator exponent from the numerator. So here, for example, we said that it will be a to the power m minus n. That's if m is greater than n. Now, if m and n are the same, we know that any value raised to the power 0 is 1. So if m equal to n, it will be 8 to the power 0. So that will be 1. Now, if n is greater than m, then we are going to get the reciprocal. So it will be 1 over n minus m. Or we can still write a to the power m minus n, but our exponent will be negative since n is greater than n. So that's the division rule. The next rule is the parenthesis. So for example, if we have a times b, they are in the parenthesis to the power m. The m fed both a and b. So here we have a to the power m times b to the power m. The same thing if it's a division, everything is in the parenthesis. The m affected it. So it will be a to the power m divided by a to the power m. Now we know that when we are doing division, always our denominator cannot be 0. If the denominator is 0, then we cannot get any answer. There's no solution. So here we write b is not equal to 0. Now, if you have a power raised to another power, then you multiply it. So for example, here we have a to the power n, then the parenthesis to the power n. So it will be a m times n. So those are the rules. Now let's start solving some problems. So here they say we should use the rules to solve the following 5 examples. So we have 5 to the power 6 divided by 5 to the power 4. So this is division. It means we are going to subtract the exponent 4 from 6. B, we have x to the power 2 divided by x to the power 5. So this means, again, division, we have to subtract 5 from 2. But since 5 is greater than 2, we are going to get a negative answer. Then we can find the reciprocal of the value to give us the result. So let's see the result one at a time. So again, this is our first problem. 6 minus 4, because we are dividing. And the base are the same, 5 and 5. So we get 5 to the power 6 minus 4. And that will give us 5 to the power 2. Now, B, we have s squared over s to the power 5. So we find the reciprocal 1 over x, 5 minus 2. So this means our answer will be 1 over s to the power 3, or s cubed. Next also is the division x divided by y raised to the power 4. So the 4 affect both x and y. So our result will be x to the power 4 divided by y to the power 4. Now here we have 3x squared, y cubed, everything in parentheses to the power 4. The only thing we should know here is that the 4 affected all the values in the parentheses. So we get 3 to the power 4, x squared times 4. The rule said that if we have x or any value raised to a power and raised to another power, we multiply all the powers. So here we get s squared times 4. Then this will give us s cubed times 4. And our final result will be 3 to the power 4 is 81. 2 times 4 is 8. And 3 times 4 is 12. So our last problem will be, again, multiplication. We have 3 and 3, and they are multiplied. So we had exponents. So it will be 3 plus 2, and that will give us 3 to the power 5. Now we say for certain calculus operations, use of negative exponent is necessary in order to write problems in the proper form. Again, we're going to see an example what we mean by that. So sometimes we can extend the rules for positive integer exponents to all integers by dividing a to the power 0 and a to the power negative n. Now we have a 0 exponent. This is way back to elementary algebra. A to the power 0, any value raised to the power 0, the answer is 1. So let's see our negative exponent. So if I have a to the power negative n, I can find the reciprocal of it, of a. So it will be 1 over a to the power n. Now, if I have a divided by b to the power negative n, I'm just going to change, instead of a to be in the numerator, a will be denominator, then b will be the numerator. So we exchange, turn it upside down. Or you can follow the steps. If you find the reciprocal 1 over a by b, we'll see that if we do the fraction, b will come up and a will be down. So we get b over a to the power n, positive. So let's see some problem here. For example, as we said earlier, a to the power m times a to the power n, they are the same. So we had the exponent. ab to the power m means a affect m affect a, also m affect b. So it will be am and b to the power m also. Now, a divided by b all to the power m will be am divided by b to the power n also. Now, we said about the reciprocal a to the power negative n to be 1 over a to the power positive n, a to the power positive n. And division here, a to the power m divided by a to the power n, so it's division, so it will be m minus n. M is the numerator exponent. Now, if you have any power raised to a power m raised to the another power n, we multiply the powers. Then we saw the special exponent 0. A to the power 0 is always 1. And also we saw the reciprocal. A divided by b to the power negative n is the same as b divided by a to the power positive n. So let's see an example now. Here they say we should simplify the following using all the rules that we went through. So first we have 2 to the power 3 times x to the power 4, y to the power 5, everything raised to the power negative 2. So the first thing I can do is to find the reciprocal of everything and change it. Change the negative 2 to positive 2. Or I'm going to multiply negative 2 by all the exponents. Then we find individual if necessary. If anytime we have negative exponent, we find the reciprocal. If we don't have no negative exponent, then we don't need to find the reciprocal. And that's the best way to solve this problem. So here you can see first thing, we multiply negative 2 times positive 3. So that gives us negative 6. Negative 2 times negative 4 will give me positive 8. Then negative 2 times positive 5 will give me negative 10. So this means we have to find the reciprocal of 2 to the power negative 6 and also y to the power negative 10. So we get 1 over 2 to the power 6 times x to the power 8 times 1 over y to the power 10. And that will give us s to the power 8 divided by 2 to the power 6 will give us 64 times y to the power 10. Now let's see the second problem. The second problem, we can see that we have x squared y to the power 0. So that means everything in the parentheses will be 1. So we write the 1 down. Now, sometimes again, we can cancel. So far, we haven't canceled yet. I can see that here I have s to the power -4. So reciprocal of this, it will bring the value up and it will be positive. So it will be x times s to the power 4. Or we have to find reciprocal of this. Here also, if we like, we have 2 here. And this will give us 16. So we can cancel 2 can go into 16. And then y squared is by itself, so we leave it. So we can do some cancellation with 2 and 4 to the power 2. And also we can combine s to the power 4 and s to the power -4. So let's see the solution. So first thing, we separate 2 divided by 4 to the power 2 because we can do some cancellation. Also, we separate the s to the power 4 divided by s to the power -4 because we can do some cancellation or combine. So as we said, -4, reciprocal of it will be positive, but the value will come up. So it will be s to the power 4 times s to the power 4. So that will give us s to the power 8. Y squared, we didn't do anything. 4 squared give us 16. So 2 can go into 16 will give us 8. So our final solution will be x to the power 8 divided by 8 and the y squared. So that will be the conclusion of our lectures. And again, see you in the next lectures. Thank you.